Good evening, one and all. We'll start in 5 minutes once everyone joins. So good evening, everyone. Let's start with today's session. I will share my screen. Yes, it's visible to you. So welcome to the 12th live session for physico-chemical processes for uh, wastewater treatment. This is the actually last live session. Tomorrow again we will be having one extra session for a few of your doubt solving if you have any, and also we can do the revision of the entire course, and we will try having some numericals, right? So you can come up with your doubts tomorrow, same timing at 7 p.m., and tomorrow will be the last live session for the course. So let's start with today's session. And yeah, so far we have discussed what all treatment methods are used for any industrial wastewater treatment plant. And basically we had classified all the treatment units into primary, secondary, and tertiary. And later we could uh, discuss each of the treatment procedure, right? So now we, from the last class, like we had discussed one such industry, and depending on the type of industry and their unit process, the this pollutant type, the amount of pollutant, and hence the wastewater composition and characteristics, they change, right? So we have been discussing various industries, right? And like what specific, if there is any specific need for that particular industry, what sort of specific treatment units might be used, right, for a particular industry. So in the last class, I guess we discussed on sugar industry, right? So in the last class we discussed that. So now we will be discussing on distilleries, right? So uh, do you know what distilleries mean and why, like how its name is derived, what sort of uh, wastewater it generates? Anybody? Yeah, so distillery is basically an industry which is used for the production of alcohol, right? And that alcohol, it can be like absolute ethanol or any isopropyl alcohol, or it can be uh, the alcohol used for like as beverages, right? So uh, it's basically a class of industry, right? So mainly production of alcohol in distillery is done by distillation, right? And it is generated by the fermentation of grain, fruits, or vegetables, right? So basically, we had seen that sucrose and sucrose, it gets converted into glucose and fructose, right? And this glucose and fructose, when undergoes fermentation, so it produces ethanol, right? Which is nothing but alcohol. So basically, you need a sucrose source, and which could be from like any vegetable, fruit, right? Because they have all carbohydrates and sugar in it. So the effluent coming from this industry hence contains color. It contains high amount of organics and inorganics, right? So why organics? Because we have been dealing with grain, fruit, vegetables, and we convert it into sucrose, alcohol, glucose, fructose, right? So all this contributes to high organic uh, loading in the effluent. Now, depending on the raw material you use, you can further classify, or depending on the amount of alcohol or type of, like for example, you want to have um, alcoholic drinks. So depending on the concentration of alcohol, depending on the flavor, your industry might vary or the process might vary slightly. So it can be classified as malty, where malt is produced from grains and less commonly from wheat or cereals, right? And then you can have brewery, which is, you can say, uh, beer, right? Beer or wine can be produced. So malt is milled to very fine coarse flour, and then it is extracted in water to produce further alcohol. And then you can, like, this was different raw material. Then you can have distillery, where you can use cereals and molasses, and here you use cereals and molasses. First goes hydrolysis, then fermentation, and whatever the products you have, you send it to distillation. So this are the processes involved. So since cereals, molasses, they are of bigger sizes, bigger chunks, you need to first crush it, right? So milling is provided. Now then you provide cooking and like hydrolysis and conversion, followed by fermentation, where you see this glucose and fructose which are produced, they get converted into ethanol. So this is a fermentation process which um, occurs in the presence of yeast, right? And you again have, in this industry, you again have the reactor, or you have yeast propagation unit, where yeast is cultured, so that you will be using that yeast uh, for uh, for the fermentation process. And this cooking and conversion is for the hydrolysis of sucrose, which is present in your raw material. Then lastly, you will provide distillation, which is for the separation of alcohol from water, right? And yeah, again, there is a trick for obtaining absolute alcohol, right? So can you define what is distillation and what could be the difficulty in having absolute alcohol? Yeah, so distillation is a process where you separate any two liquids, or maybe it can be more than two liquids, based on the difference in the boiling points, right? Yes, there is some network issue. We will wait for a minute to join. Yeah, sorry, I got disconnected from the session because of poor network. Yeah, so we were discussing what is distillation and how it is used for ethanol production or alcohol production, especially absolute alcohol. Like, what do you mean by absolute alcohol when you have very pure, greater than 99%? If purity, right? So distillation here, you at the end you will have um, ethanol and water mixture, right? So solution will have ethanol and water in it. So you will be separating this by using distillation, where you use difference in boiling points of two compounds for their separation. So the one with lower boiling point, here in this case ethanol, will be obtained at top of the column. So basically you will have a column where the separation happens, and higher boiling of, like, if here water, it is obtained at bottom. Ethanol has around 77 degrees boiling point, if I'm not wrong. This has around 100, right? So this is at atmospheric pressure. Now what happens is, if you want to produce absolute alcohol, then this water and ethanol, they form a constant boiling mixture, which are also termed as azeotropes, which means that now you don't have any difference in boiling point. And since you don't have any difference in boiling point, like, simple distillation cannot be used, which is like the basis for application of distillation column. So now you need some special technique, for example azeotropic distillation, where you can have different pressure for operation of distillation column or some other variation you can have, right? So as to have absolute alcohol. uh yeah, I guess, I hope this is clear, like what do you mean by azeotropes. And ethanol and water, they form azeotrope at around 95% concentration of ethanol, and it will have 5% still impurity of water, which means you are not able to have actually absolute alcohol, right? So this is about the process and the difficulties during the process and what sort of technologies you have while the production of alcohol. Then talking about the wastewater generation during the process, like it could be out of the process used for the synthesis, or it could be out of uh, any non-process operation. For example, cooling tower, where you are not directly using that water into the process, but through for some indirect operation, like you will use that water for heat exchangers, right? Then water for washing, boiler blowdown, etc. And if you talk about process, then it could be spent wash, fermenter sludge from spent wash from rectifier, right? And since all these processes, they have involvement of these raw materials, including like which contains sucrose, and again it will have yeast, so it will be high organics. And out of these organics also, it will have high, like uh, the amount of biodegradables will be more. So yeah, so wastewater are like, it is high in BOD and suspended solids, as compared to like BOD and COD will be equivalent in this case because of the usage of um organic raw materials, right? So which are biodegradable in nature. So this type of high BOD and COD, like high BOD contain the wastewater, you can have biological treatment by using activated sludge process or trickling filters. Yeah, and if you still have very high concentrations of BOD, in that case, you first treat it in an anaerobic condition, so that like bacteria or microbes, they are like they can be used only up to a certain limit of BOD or COD. Above that limit, first you need to provide anaerobic treatment and later the aerobic treatment. So depending on the BOD concentration, you can choose which one to go for first, right? So uh, this was about the distillery industry and what are the characteristics of wastewater in it, and what sort of uh, uh, technologies you use. And yeah, so moving forward, we have fertilizer industry. So fertilizer industry is any industry where you produce the nutrients required or the elements required for the growth of plant, right? So it could be containing nitrogen, phosphorus, or potassium. So any compound which contains nitrogen, phosphorus, or potassium, that come into the category of fertilizer industry, right? So it could be straight, which means you just have only one nutrient being produced, right? Or it can be complex fertilizer containing two or more elements of fertilizer, right? So straight could be urea, ammonium salts, ammon uh, calcium ammonium nitrate, and complex could be diammonium phosphate, ammonium nitrophosphate. Okay, so uh, yeah, so the wastewater coming from any of these industries would be rich in nitrogen, phosphorus, sorry, right? And nitrogen also further can be found in the form of um organic nitrogen, ammonia, nitrate, nitrites, right? And there are different ways of finding out what type of nitrogen is present. So, and there could be some different standards also available for each of these nitrogen forms also, right? So you can have total nitrogen and like, which means all the sort of nitrogen you have, and this is a sort of method by which you can measure the amount of nitrogen. Yeah, so now if you talk about the effluents from each type of fertilizer industry, for example ammonia plant, so which means you have synthesis of ammonia, and ammonia is usually synthesized by, like, since it is NH3, it is synthesized from N2 and H2, right? So this is the uh, raw material and the reaction, sorry, like this is a reversible reaction with a very low conversion. So the main processed wastewater can have condensate containing ammonia, methanol. Now, in all the industries, you can have oil bearing effluent because of the, for example, you are washing any reactor, and oiling will be always done for the maintenance and for, like, for example, you have walls, you have some rotating unit, then oil and grease will be provided. So in that case, oil containing effluents will always be there. And then you can have stripping operation. For example, ammonia needs to be separated for, since this is in gaseous form, ammonia needs to be stripped off, and you can have some absorption unit or steam stripper. So in that case, the water might come into the contact of any of these chemicals. For example, this is diethanolamine, which is again an absorber, monoethanolamine, which is again an absorber, right? So these sort of chemicals, they end up into the wastewater stream, right? Next is, if you talk about urea plant, then urea is synthesized from ammonia and carbon dioxide, right? So the majority of wastewater content will be ammonia, urea, and carbon dioxide, and you need to have specific treatments. For example, if you want to separate CO2, you need to have absorption tower. Now again, you will have chemical absorbers, for example monoethanolamine, diethanolamine, they all are used for CO2 absorption as well. So that can end up in water further, and you need to have treatment. And urea and ammonia again can be present. Then if you talk about nitric acid plant or even sulfuric acid plant, you can have acidic wastewater because of the spillage and leakage. And if you talk about super phosphate plant, you will obviously have high phosphate content, and you can have still have fluoride and suspended solids. Now, phosphate is usually derived from phosphate ores or rocks are used. Hence, you, like, during the crushing milling, you can have generation of lot of suspended solids in this case. And lastly, NPK plant, you can have leakage from pump glands, wastewater from draining and washing of equipments. Now, if you want to treat all such sort of effluents, you can have, for example, if you have a gaseous stream in water, then you can obviously use stripping, where you can change the temperature of the gaseous stream so that, or sorry, if you have gas dissolved in water, you can go for stripping, so that you are lowering the solubility of gas, and at the end you are collecting the gas from the separated from water stream. Then you can have ion exchange if you have, for example, um, uh, wastewater containing high amounts of hardness, reverse osmosis chlorination. And when you have high amounts of nitrogen, obviously you need to go for nitrification, denitrification, where you are converting ammonical nitrogen first to nitrates and nitrites, right, and then it to N2. So this is nitrification, denitrification, which again takes place in the presence of microbes, and hence that is why we call it as a biological process. uh, yeah, again same applies for urea plant. And yeah, so let's move forward. Do you have any doubts so far?
No, ma'am.
Okay. um yeah, so next is petroleum industry. So if you talk about petroleum industry, it basically means you are deriving all sorts of petrochemical products which you use in your day-to-day life, and petrol, diesel, kerosene, um, jet fuel, all sort of fuels also from petroleum industry, right? So petroleum and petrochemical industry, they are all interrelated, and it all starts from refining of crude oil, right? So if you have heard of what are the contents of crude oil, then it contains n number of petrochemical or petroleum products which you cannot even think of. And there are certain impurities, for example sulfur, it can be treated as impurity. And if you would have heard of for example petrol or gasoline, then you would have heard of octane number, or which means that the purity of gasoline is this much percentage, and this is defined by the sulfur content of that fuel also. So here in this crude oil refining, you have major type of pollutants including sulfur compounds, because you need to have removal of sulfur maybe after the production of that particular compound. So what happens here is you have many distillation columns, right? And as we mentioned, distillation column operates under the difference of, like, on the basis of difference in the boiling points of each of the compounds. So you will have different cuts in a distillation column where you will be recovering. For example, you will have first the gaseous products, then you can have gasoline, then you can have jet fuel, diesel, right? So then you will have the product which goes to again vacuum. So this operates under atmospheric condition, that is why it is known as ADU, which is atmospheric distillation unit. And next is VDU, which operates under vacuum. Now, why vacuum? Because as you go towards vacuum, the boiling points, or the high boiling point, uh, or the high boiling liquids, they get converted into, like, its boiling point reduces, and you need to have lower boiling, like the boiling point reduces, and hence you can recover that particular fraction. So this will be VDU. So as you are generating a lot of organic compounds, this the wastewater from these uh, plant will have very high organics or hydrocarbons, right? Then oils, and for example, you have some impure crude oil, then obviously it will have some impurities in the form of inorganics like metals. And also, as I mentioned, for example, gasoline, then this gasoline might have sulfur, high sulfur or low sulfur content depending on where you are procuring the crude oil. So now if it has high amount of sulfur, then desulfurization is an important process which is usually provided to each of these cuts. So you can have high sulfur containing compounds and H2S or sulfates from this wastewater. So some of the organics you can remove by activated carbon, or you need to have, uh, for example, you this mm, if you go for biological treatment process, then it will be very high load. So you can have anaerobic process, or you can also need further the tertiary treatment for the, for example, advanced oxidation process for the oxidation of all the compounds, because most of them are oxidizable, and that is why you might need tertiary, or you will be needing this tertiary treatment. For example, if you have H2S, then the final oxidized product will be sulfates, right? So it all, for all the inorganics and organics, you will be needing oxidation process. Next is we will be talking about common effluent treatment plant. So which is nothing but normally known as CTP. So this type of plants are usually installed in where there is a cluster of small to medium scale industry, and since these small and medium scale industry, they lack the space, and they lack the ability or that much infrastructure for the treatment or complete treatment of wastewater, their CTP comes into role, where the industries which lack in fund as well, it treats all the wastewater coming from that cluster or from that region of industrial zone, where all the industries, they send their wastewaters with or without some preliminary treatment, right? So this adds up into the advantages, like it reduces the cost of treatment, because you are treating all the wastewater at a time. It is addresses the issue of lack of space, right? So it becomes more affordable, and you will have only one, like it eliminates the multiple discharge from within one area, right? So these are its advantages, but again you have some disadvantages. For example, the wastewater which are coming from different industries, they might have very different characteristics, so you need to have a treatment plant which is capable of treating that much different characteristics of wastewater. Also you need to take care of all sorts of low variation in the flow rate, all sorts of variation in the type of pollutants if it has, because small and medium scale industries, they operate in batch mode more, right? So in that case you will have generation of wastewater, but depending on the batch that you are operating, the characteristics of wastewater might also change further, right? So in that case also, like it's quite tricky to operate, um, or rather I would say design a common effluent treatment plant considering all sorts of industries you are looking into. So yeah, these are some of the drawbacks. And as I mentioned that there are a lot of fluctuations for the effluent, like, right? So in that case you always have an equalization tank so that you minimize the shock loads to the instruments which are downstream the process. So you try to minimize the shock for the further treatments, and you will have a uniform flow rate which are going to the further processes. Then also you can have waste minimization by adopting specific processes which are generating lesser amount of pollution. So you can have different, for example, if uh, these are nothing but batch processes, then you can modify your process a bit so that you have generation of waste which is lesser toxic, or I you can say which generates less amount of wastewater or with low concentration also. And since these CETP earlier actually used to take the wastewater as it is without any preliminary treatment, but nowadays there are guidelines for uh, the specific industry also to have some sort of preliminary treatment, if especially if they have certain different pollutant which might be more toxic, right? So all sorts of uh, guidelines are provided by CETP for the industries which generate the wastewater and they send. So there will be a lot of guidelines, and again if the guidelines are not met by all the small scale industry, they impose heavy fines. And this guidelines could be the amount of wastewater generated, the flow rate, and again the concentrations of all the pollutants which are present in the wastewater. So to take care of all these guidelines, you obviously need to have some preliminary treatment so that it's less tricky for to operate a CETP. Okay, so I will just be back in a minute. Please give me some time. Okay, let's move forward. Then we have, yeah, so depending like what sort of treatment technology you use depending on the characteristics of wastewater. So that is nothing but first we say what is the treatability of water or treatability studies, where depending on the chemical composition you identify what sort of technologies might be required for this particular effort. So, and further, the treatment are decided based on the TDS, COD, and BOD amounts. For example, it can be classified as high TDS, high BOD, and equivalent COD. Then you can have low BOD, equivalent COD. Then you can have high BOD, high COD. Um, and again, you can have low BOD, high COD, and you can have high BOD and large difference in. So the basic thumb rule is, for example, if you want to decide any uh, so here you have high or low TDS, and these are the cases for BOD and COD. So for instance, you want to decide the treatment technology based on the BOD and COD amounts. So what you do, you first check the BOD and COD amount of that wastewater, and you classify it as whether it is high, like there will be certain thumb rules. For example, you can use activated sludge process only up to a certain limit of BOD concentration, right? So depending on those guidelines, you decide whether the BOD is high, BOD is low. And when you have BOD to COD ratio above, let's say, 0.7, then you can say that or you can say you have high BOD but almost equivalent COD, which means all sort of COD with chemical oxidation demand you have, that is because of majorly because of the biodegradable organics. In that case, you can use biological process for the degradation. But now if you have very high BOD, very high, so I guess in the lectures, the specific concentration is also mentioned. I forgot actually. So very high BOD, you can check that. So in that case, you need to have anaerobic treatment first, which can be followed by aerobic treatment, including activated sludge process, trickling med filters, lagoons, etc. Followed by aerobic, right? So this could be the sequence, and if you have very low BOD and high COD, in that case you can have some other thermal degradation, or you can have advanced oxidation processes where you are supplying some chemicals for the oxidation, right? So like this, you will be required to decide whether uh, uh, you like what sort of process is required. Again, if you have medium sort of both high BOD and high COD, you might require both biological treatment and again which will be followed by thermal degradation as well, right? So that sort of combination will always be required depending on the BOD and COD concentrations and the biodegradability of your wastewater. And if you talk about the disposal, then nowadays there is a you know, if you talk about CTP or any major large scale industry, for example, Reliance, Tata, then they operate in different modes, right? So for small industries, you have CETP. For large industries, they have their own effluent treatment plant. In both the cases, nowadays there is a rule that you should not have any water which is discharged in liquid form out of the plant. So you are not allowed to discharge any liquid water out of your plant, which means you need to completely recycle your water stream by recovering pure water to any form. It could be processed water, it could be used for boilers, for generating steam, depending on the purity of water you are recovering, right? So this term means, like, since you are not discharging any liquid out of your water, so it means it is zero liquid discharge, right? So zero liquid discharge is nowadays followed majorly everywhere. And what you do with the pollutants, so what you are basically you doing, you are concentrating water such that you have two streams. So you can, for example, you can degrade a few uh, pollutants, for example, organics. So you will have uh, get it converted into CO2 and water, right? But again, you have byproduct of microbes which are in solid form. So it will stay, which requires sedimentation. So you are purifying water at every stage. So you will be recovering water at every stage, and last will be RO or multiple effect evaporators, where you generate pure water which can be recycled back, and you have very concentrated stream. So in uh, last process that you use in ZLD plant will be spray dryers, where the wastewater or the concentrated stream, you will have two streams of water, pure and one is concentrated. So the concentrated stream goes to the spray dryer, and spray dryer, what it again does, water and solid, they are separated, right? So water in the form of droplet is sprayed from the top of a tower, and a very hot air is passed in the counter current mode. Let me show you. So you will have let's say this is the tower, you spray, you will have nozzles here. So you spray wastewater concentrated, um, these are the droplets, and you have very hot air passed in counter current mode, right? So as water comes in contact with hot air, this water gets evaporated, and this air, it will have, now when it comes out, it will have water vapor along with it. Now you can definitely condense it. So again, if you want to recover this heat out of what waste water vapor, you can use it in heat exchanger, or you can use it in boilers for generating steam, right? So high pressure steam, I would say. So this sort of recycling is nothing but it is termed as uh, you know process. So this sort of recycling and process intensification uh, is used nowadays everywhere. It could be any raw material, it could be any byproduct. So nowadays they all are recycled back into the plant. And at the end here you will have solids which contains all sort of pollutants. It could be metals also, it could be suspended solids, it could be sludge from activated sludge process, right? So all sort of dry solid you will have which will be sent to landfill sites, right? So landfills it is sent. And yeah, there could be some hazards or accidents in industry as well, which can be natural hazard because of some natural flooding, etc. Then you can have accidents in your plants also, and such hazards you need to always be prepared of those hazards as well. Yeah, so that's it for the class lectures. We will move forward towards the assignment. Before that, if you have any doubt, you can do let me know. So let's proceed with the assignment. So first question here is, the process waste streams are one of the major sources of wastewater for molasses based distilleries, and which of the following is not a process waste stream? So let's look into the options. Boiler blow down, then you have spent lees from rectifier, fermenter sludge, spent wash. So all these sort of waste are from the processes which converts molasses into alcohol, right? So this are nothing but termed as process waste water or process waste stream. While boiler is nothing but used an indirect process which is normally used to generate steam, high pressure steam, and that is used in heat exchangers and uh, generating electricity and so on, right? So boiler is not a direct process waste stream, so the correct answer here is boiler. Next is, what is the discharge limit for ammonical nitrogen according to effluent discharge standards for straight nitrogenous fertilizers prescribed under Environment Protection Rule? So it is 50 milligram, 50 milligrams per liter. Next is common effluent CETP is, it stands for common effluent treatment plant, right? So it is option D. Next question is, the activated sludge process comes under the following. It is a secondary process where you use microbes, right? Because this comes under the category of biological process and which are usually used as secondary process. Then you have, what is the maximum discharge limit of nitrate nitrogen according to effluent discharge standards? So it is 10 again milligrams per liter. You take care of the units every time. Usually for discharge standards you will have milligrams per liter, or it is also known as ppm or parts per million, right? So you take care of the limit units. Next question is, the Indian fermentation industry is categorized as maltery, brewery and distillery based on either molasses or grain used, right? So depending on the raw material you are using for the generation of alcohol, it can be classified. The brewery, sorry, the brewery process requires a significant amount of water and the produced wastewater is high in dash and suspended solid content. So it has high BOD. And why does it have high BOD? Because of the usage of um, Sucrose containing raw materials including vegetables, cereals, grains, right? Which convert gets converted into sucrose, and later it gets converted to glucose, fructose, to ethanol, right? So all these are source of nothing but biodegradable organics, which means it is rich in BOD, right? So high BOD contain wastewater. Then what is the limit of free ammonical nitrogen according to effluent discharge, which is 4 milligram per liter. ZLD, it is zero liquid discharge, option C. Last question, which water treatment is generally used in households for drinking water purposes? So water treatment in households usually have reverse osmosis, right? And if you see sedimentation, ion exchange, activated sludge process, all these, even RO is used in industries, but if you talk about other processes, they are very specific for industries. While RO, if you talk, it is used in households as well as industries both, right? So for household, the correct answer would be RO here. Yeah, so that's it from my side today. You can come up with your doubts if you have any. Uh, I'm here for some time more, and again, we will meet tomorrow at 7 p.m. for the extra class, extra doubt session. So you can come up with your doubts if you have any. Otherwise, I'm like, this was it from my side today.
Thank you,
Thank you.
ma'am.
Yeah, thank you. Okay, so I guess nobody is here and nobody has any more doubts. So I will end this class for today. We will meet tomorrow again at 7 p.m. Thank you everyone for joining.